Hello everyone, welcome to our channel 2 Bits. In this video, we are going to start with trees. So before moving forward with problems on trees, we will learn some terminologies related to trees. So before starting, you should be familiar with recursion and linked lists. Those who are new to this channel, we have solved many problems on linked lists, so please watch that before moving on to this. So let's see what is a tree. A tree is a non-linear and hierarchical data structure consisting of a collection of nodes. There are two types of data structures, linear and non-linear. Linear consists of arrays, stacks, queues and linked lists, while non-linear consists data structures like graph and trees. The first node in a tree is called a root node, and these are called the edges. The node which has no child is called a leaf node, like 4, 5, 6, 7 and 8. These nodes have no children, so these are called a leaf node. Now 4, 5 and 6 are children of the node 2, and 2 is the parent of 4, 5 and 6. Now let's see what is a binary tree. A binary tree is a data structure in which each node has at most 2 children, which means a node can have either 0 or 1 or 2 children. For example, here 2 has 2 children, 4 and 5, while the node 3 has only one child, that is 6, and 4, 5 and 6 have no children, so they are leaf nodes. Now let's see what is a complete binary tree. A complete binary tree is a binary tree in which all the levels are completely filled except possibly the lowest one, which is filled from the left. All levels are completely filled means that all internal nodes have 2 children, and the last level must have the nodes as left as possible. That means the last level is filled from left to right. For example, in this case, all the levels are completely filled, and the last level, all the nodes are as left as possible. Now in this case, this level is not completely filled as 3 is missing a right child. And in the last level, the nodes are not as left as possible because 4 is missing a right child and 5 is missing a left child. So this is not a complete binary tree. Now let's see what is a full binary tree. A full binary tree can be defined as a binary tree in which all the nodes have 0 or 2 children. For example, here each node has either 0 child or 2 children. For example, here 2 has no child and the node 3 has 2 children, 4 and 5. Similarly, the node 4 has 2 children, 6 and 7. Now let's move on to perfect binary tree. A perfect binary tree is a type of binary tree in which every internal node has exactly 2 child nodes and all the leaf nodes are at the same level. For example, in this case, each internal node has exactly 2 children and all the leaf nodes are at the same level, which means there is no leaf node except in the last level. So this is a perfect binary tree. Now let's see what is a binary search tree. A binary search tree is a tree in which internal nodes each store a key greater than all the keys in the node's left subtree and less than those in the right subtree. For example, here the root node has the value 30 and all the nodes in the left subtree are less than 30 and all the nodes in the right subtree are greater than 30. And this goes for each node in the tree. For example, here all the nodes in the left subtree of 20 are less than 20 and all the nodes in the right side are greater than 20. Similarly, for 40, all the nodes in the left subtree are less than 40 and all the nodes in the right subtree are greater than 40. So this is a binary search tree. In the next video, we will be starting with traversal of a tree, and Then we will solve some problems on trees, and we will be covering all the problems from easy to hard. So please stay with me and subscribe to our channel 2 Bits.